Okay, for this question here, we're going to determine if this set of 4 vectors are going to span R4. So there's a bunch of ways we can do it. We'll learn some more later on. But for this way, what we're basically saying is there's some like A, B, C, D, so that A times the first plus B times the second, C times the third, D times the fourth is equal to literally any vector in R4. So the way that we can do this is actually just putting this into a column matrix. So I'll put all of these in here. Like this. And 1, -4, 5, 0. And the thing we'd have on the right of this is like literally anything. So like any combination of like a 4-entry vector in R4, literally anything. We're trying to see if there's like something in R4 that gets missed by this. And basically the quick way to do this would be to just reduce these things on the left without really paying attention to what's going on the right. Because if these things give us a 0 row, like we'll be able to generate something that's a problem. And I'll go back and show you at the end how we could construct that. But let's say, we'll do our row reduction. So I will do 3 of the first from the second. So I would get 7, 2, -7, and add 5 of the first to the third. That'd be 10. Second and third rows are at least somewhat similar. And okay, so kind of just ignoring the thing on the right here. I'm going to, I don't know, maybe I'll multiply the second row by 3. Just so that I can kind of cleanly turn it into a 1 by adding 2 of the next row. Seems like a nice trick. So just keep repeating things here. Yeah, so now I'm going to add 2 of the next row to get my 1 here. And 2 of the next row will put me in a -1 there. And then I'll get rid of this 10 in the next step. So I'll have 1. So I'm going to add 2 of the second row to this. So 16, -1. And then I will get 0, -10. Oh, no, I'm getting rid of this. So I'm going to add 10 of this row to this one. That'll be 81. And 10 of this row to that will actually put a 0 there. What I can see is that 0, 0, -1, 0 is going to wipe out the 81. So I am actually going to get a 0 row here. And I can actually just use that to wipe out everything here if I want. 0, and I'll push it up, make it positive. So yeah, so we should get something like this. What we can see though is that there's a 0 row. So some x in R4 will not be in this span. And so no, it does not span R4. So I've just added a bunch of numbers here to kind of demonstrate like how we can find a particular vector in R4 that maybe doesn't get found by the span of the set. So it wasn't actually what was asked for in this question, but it's going a little bit of a step further. So like we don't know what this vector is going to be. So let's just call it ABCD. And then basically what I've done is just done the row operations to the ABCD. So for example, the second row, we got this from the second row -3 of the first row. So B -3A, etc. And basically just kind of going through and computing all these. It got a little bit messy. But at the end of the day, what we would have had in that 0 row on the right-hand side is this expression here. And as long as this is not 0, we would get no solution. So any combination of A, B, C, D that makes that not 0 gives you no solution. There's definitely some that could give you 0, but just maybe some like very simple examples would be your standard vectors. So like 1, 0, 0, 0, or 0, 1, 0, 0. None of these will actually be in the span of these 4 vectors. In fact, probably anything you randomly chose would actually not be in the span of those 4 vectors. Most vectors will not be in that span. So it obviously does not cover all of R4.